In this video, we will review some transformation rules, and we will look at two special functions. First off, some transformation review. If you have some constant added at the end, it makes it go up by that amount. So we would have that this goes up c. If we have our function subtract some constant, that'll make it go down c. Remember, inside the parentheses is opposite of what you would think. So if you have x plus c, that actually makes you go left c. And if you have x minus c, that actually makes you go right c. When you have a value out front, assuming that c is a number bigger than 1, we could either say that we multiply the y's by c, or you could also say, again, this is assuming that c is some number greater than 1, we could say vertical stretch by a factor of c. Similar idea for the next one, we could say that we multiply the y's by 1 over c, or assuming c is some number greater than 1, we could say that it is a vertical compression. You could also say a shrink. You might have seen that terminology before. Vertical compression by a factor of 1 over c. Now remember, inside the parentheses, it's opposite of what you would think. So if we have c in front of x, we actually multiply the x's by 1 over c. And again, assuming that c is some number greater than 1, this would be a horizontal compression by a factor of 1 over c. For the next one, we're multiplying the x's again by the reciprocal, so by c. So again, assuming c is some number greater than 1, when you multiply by a number greater than 1, it makes things bigger. So this would be a horizontal stretch by a factor of c. Our last two are reflections. Inside the parentheses always affects x's, outside always affects y values. So this first one here, we're negating the y values. Well, when you negate a y value, it causes it to go from left to right or right to left. So basically, whichever value you negate, it flips over the opposite axis. So when we negate the y values here, it actually reflects over the x-axis. So in this picture here, we had the x's negated. That's actually the second one. The one we just had here, if we negated the y's, as you can see, it reflects over the x-axis. So maybe this is 1, 5. This becomes 1, negative 5. Here, this is 5, 1. That will become negative 5, 1. So when the x gets negated, it flips over the y-axis. So the second one reflects over the y-axis. Okay, whatever value is negated, it flips over the opposite axis. Inside the parentheses is x's. Outside the parentheses always affects the y's. So that shouldn't be anything new. That's just a little review because we're going to use them with our two new functions. The first function is what's called the signum function. It can be written as y equals signum x or abbreviated as y equals sgn x. How the signum function is defined: if your x values are negative, the y value is negative 1. If your x value is 0, the y value is 0, And if your x value is positive, your y value is positive 1. The graph of it is shown. So again, negative x's produce a negative 1 y value, positive x's produce a positive 1 y value, and an x value of 0 gives you a y value of 0. Now, there's no exact way to graph this on your calculator, but we can approximate it by graphing absolute value of x over x. The only place this will not work is at 0. In representing it as absolute value of x over x, 0 would actually make the denominator undefined, so you wouldn't have any point there. But you would get the horizontal line at 1 when x is positive and at negative 1 when x is negative. So to somewhat represent it, you could graph it as that. And what we're going to do is we're just going to look at a couple shifts of this original function. So the first one here, we have signum and in parentheses x plus 5. Well, if you have a plus 5 inside the parentheses, it actually shifts it opposite of what you would think, and it's going to shift 5 to the left. So our spot that was at 0 is now at negative 5. So again, we'll plot that point that was at 0 at negative 5, and then we'll have the open circle above going to the right, open circle below going to the left, because we just took our original signum function and shifted it 5 to the left. Now, in the next one, we have a minus 3 at the end. That should just shift our function down 3. So the point that was at 0, 0 is now at 0, negative 3. We got open circle above going to the right, open circle below going to the left. So that is just a couple transformations of our signum function. Now, another function we'll work with is the greatest integer function. It is notated by those square brackets there. And what the greatest integer function means is the y value will be whatever integer is less than or equal to x. Now here's a graph of it on the right. So notice when our x values are between 0 and 1, but not including 1, it takes on the y value of 0. Because for those decimal x values, the integer that is less than or equal to it would be 0. Notice from 1 to 2, but not including 2, our y values are 1, because when x values are 1 or 1 point anything, the integer that is less than or equal to it is 1. Likewise, when our x's are 2 or 2 point something, the integer that is less than or equal to it is 2, so it takes on the y values of 2. So if we want the greatest integer of 5.6 there on the left, the integer that is less than or equal to 5.6 would be 5. The integer that is less than or equal to negative 6.2. This is where it becomes tricky, because on a number line, you've got to think of it as you're always going to the integer to the left of it if it is not an integer itself. So the integer to the left of negative 6.2 would be negative 7. Pi is really 3.14, so if you go to the integer to the left of that, that would just be 3. And 4 is an integer, so that's all set as it is, because it's the integer that's less than or equal to your x value. It's an integer itself, so it just keeps its value. And that's where those closed circles are coming in on the graph. Notice 4, 4, we have a closed circle at that point. And each of our things here you could confirm from our graph. If you look where 5.6 would be on the x-axis, that corresponds to 5 on the y. Negative 6.2 actually goes off our graph slightly, but you could see the pattern that it would be down at negative 7. Pi 3.14 would be at 3, and then 4 is just at 4. That's it for this video. We'll see you next class, period.